In this video, we will discuss about the Vander Waals forces. Vander Waals forces are intermolecular forces which exist in all molecules. Let's we have the two atoms, that is positive charge lies at the center of the atoms, while the electron cloud which is revolving around the positively charged nucleus. As the electron cloud is evenly distributed around the positively charged nucleus, so in such a situation, these atoms are called as nonpolar. These are the nonpolar atoms. As we know that the electron cloud is constantly moving around the positively charged nucleus, electrons are moving, revolving around the nucleus. These are the electrons are not static, rather these are moving. So during its motion, at some moment, there are the more number of electrons move toward the one side, so the one side become negative, and other side which has the less number of electrons become partially positive. So there is the polarization of the charges, and now this there is not, the electron cloud is not evenly distributed around the positively charged nucleus. So here the one side is the more negative as compared to the other. So we say that in this case, the one side of atom is the partially positive and other side is partially negative. So there is the separation of the charges in this atom. In such a situation, this atom is not non-polar, rather it is called as polarized. Now it becomes polarized. There is the polarization of the charges. So such an atom becomes the dipole. So the one side is negative and other side is the positive. Now this atom is called as dipole. So one side is the positive and other side is the negative. So when this dipole interact with the nearby non-polar atom, when non-polar atom comes close to this dipole, so the positive side of this dipole will interact the electron cloud of this nearby non-polar molecule. There is the interaction between the this dipole and this non-polar atom. So the positive charge attract the electron cloud of this non-polar molecule towards itself. So the electron cloud move towards the positive end of nearby dipole. As a result, these non-polar molecules become polarized. So this is also, now this is the polarized. So whenever the one atom become polarized, so it can induce the polarization in the nearest non-polar atoms. So the nearby non-polar atom also become polarized. So there is the separation of charges in this atom as well. So the positive electron cloud attracted towards the positive end of this dipole. So this atom also become dipole. So this is the dipole. Now we look at two dipoles, and this one dipole and this one dipole, as the positive end of this dipole interact with the negative end of this dipole. So there is interaction between two dipole, as one side is the positive and the dipole and the other dipole has negative charge. So there is the force of attraction between the positive end of this dipole and negative end of this dipole. So this force of interaction between two dipoles is called as Van der Waals forces or London dispersion forces. So this dipole is also called as temporary dipole. The reason why it is temporary dipole is that as the electron cloud is constantly moving around the positively charged nucleus, it's not static, it is constantly moving. So during motion, at one moment, when more electron comes to one side as compared to the other, so more electron gather on one side, so that side become partially negative as compared to the other side, which become partially positive. So as a result, that non-polar atom become the polarized or become dipoles. So on the other moment, as the electron are constantly moving, so on the other moment this polarized atom can restore its non-polarized state. So again the electron cloud becomes evenly distributed again. So electron cloud is evenly distributed again, it becomes the non-polar atom. So that's why it is called as the temporary dipole, because it can restore its original non-polar state. So the other dipole, which is called as induced dipole, reason why it is induced dipole is that because it is dipole moment in this atom is induced by this temporary dipole. When this atom becomes temporary dipole, the positive end of this dipole interact with the electron cloud of this nonpolar atom. As a result, the electron cloud attracted towards the positive end of this dipole. As a result, this non-polar molecule atom also become polarized. As a result, it becomes dipole. So this temporary dipole can induce the dipole moment in this non-polar atom. That's why it is called as non-polar non-induced dipole. This atom called as induced dipole. So if we look at the fluorine has the 9 electron, while the iodine, which has the 53 electron. So here we need to understand the term polarizability. As the iodine has the more number of electrons, so it can more likely become polarized. It has the more tendency to become dipole as compared to the fluorine. Okay, now we can say that the dominant forces in non-polar molecules are the Vander Waal forces, while the Vander Waal forces are the weak forces in the case of polar molecules. So now if you look at the trend in the case of halogens, like we have the fluorine. Fluorine, which exists in the gaseous state, its boiling point is minus 188 degrees centigrade, while its molecular weight is 38 degree and it has the 9 electron. If you look at the chlorine, which also exists in the gaseous state, its boiling point is minus 34 degrees centigrade and its molecular weight is 70.9, while it has 17 electrons. The bromine, which exists in the liquid state and its boiling point is 59 degrees centigrade and its molecular weight is 159.8 and it has 35 electrons. While the iodine, which exists in the solid state and its boiling point is 114 degrees centigrade and its molecular weight is 253.8, while it has the 53 electrons. If you look at the trend down in the group, like here you can see that as the number of electrons increases from fluorine to iodine, its molecular weight increases. As a result, as you go down from fluorine to iodine, their boiling point increases. So the iodine has the more boiling point as compared to the fluorine, that is minus 188 degree, and then we go down into the group, it has 114 degree and the number of electron also increases. So we can say that as the number of electron increases, their molecular weight increases. As the molecular weight increases, so the London dispersion forces increases. As the atom which have more number of electrons, they more likely become polarized. So it means that the London dispersion forces are larger in that case, in that molecule which has the more number of electron. So the number of electron increases, the London dispersion forces increases. As a result, these London dispersion forces impact the boiling point. So the boiling point also increases. So the electron increases, molecular weight increases. As a result, the London dispersion forces increases and it increases the boiling point. So the boiling point is directly related with the London dispersion force, and London dispersion force is directly related with the number of electrons. Okay, if we look at some molecules like methane, ethane, and propane and butane. If you look at the molecular formula of this, the methane has C1H4, methane has C2H6, propane it is C3H8, and for butane it is C4H10. If we look at the molecular weights, the molecular weight of methane is 16, as the carbon has the 12 molecular weight, and there are the 4 hydrogen, and hydrogen has the molecular weight 1, so it has a 16 molecular weight. And for methane it's 30, and for this one it is the 50, propane it is 44, and for butane it is the 58. If you look at the trend in the molecular weight, as the molecular weight increases, so this butane has the larger molecular weight as compared to the other, so its boiling point is larger than methane, as the methane has the lowest molecular weight, so its boiling point is lower than butane. As the molecular weight, it means that the London dispersion forces are more dominant in the case of butane as compared to the methane. Thanks for watching.